Hello, my name is Kemi Orelaja, a doctoral student of California Intercontinental University. I will be presenting a topic titled Conducting a Correlational Analysis. My agendas are: we look at the background information, we look at the 6 correlational tests using PSPP, we look at the information important takeaways, question and answers if any. Background information. The hypotheses are two-tailed hypotheses. We have the null hypothesis and the alternative hypothesis. For the null hypothesis, it says there is no correlation between the two variables, therefore R equals 0. For alternative hypothesis, there is a correlation between the two variables, therefore R is not equals to 0. The null hypothesis is rejected when p-value is less than alpha, where alpha equals 0.05. However, if p-value is greater than alpha, we fail to reject the null hypothesis. The p-value is the probability of obtaining an effect at least as extreme as the one in the sample data, assuming the truth of the null hypothesis. Alpha is referred to as the significance level. Correlation is one of the most common and useful statistics. It is a single number that describes the degree of relationship between two variables, symbolized by letter R. Correlation ranges from -1 to +1. If the correlation is negative, then the relationship is negative. If the correlation is positive, then the relationship is positive. We look at the first hypothesis test, which is between income and savings. The following correlational test was conducted. The null hypothesis states there is no correlation between participants' income and their savings amount. The alternative hypothesis states there is a correlation between the participants' income and their savings amount. The correlation coefficient and its p-value were calculated using PSPP. Assuming alpha equals 0.05, a significant correlation emerged where R equals 0.91 and P equals 0.000. The test rejected the null hypothesis and concluded there was a correlation between the participant income and the savings amount, as we could see from the graphical representation of the correlations and the scatter plot diagram between income and savings. The second hypothesis test is between income and stock. The following correlational test was conducted. Null hypothesis states there is no correlation between the participant's income and their stock portfolio valuation. The alternative hypothesis states there is a correlation between the participant's income and their stock portfolio valuation. The correlation coefficient and its p-value were calculated using PSPP, assuming alpha equals 0.05. A significant correlation emerged where R equals 0.19 and P equals 0.018. The test rejected the null hypothesis and concluded there was a correlation between the participant income and their stock portfolio valuation. The third hypothesis test is between income and wallet. The following correlational test was conducted. Null hypothesis states there is no correlation between the participant income and their wallet amount. The alternative says there is a correlation between the participant income and their wallet amount. The correlation coefficient and its p-value were calculated using PSPP. Assuming alpha equals 0.05, a significant correlation emerged where R equals 1 and P equals 0.000. The test rejected the null hypothesis and concluded there was a correlation between the participant's income and their wallet amount. The fourth hypothesis is between savings and stocks. The following correlational test was conducted. Null hypothesis states there is no correlation between the participant's savings and their stock valuation. Alternative hypothesis states there is a correlation between the participant's savings and the stock valuation. The correlation coefficient and its p-value were calculated using PSPP. Assuming alpha equals 0.05, a significant correlation emerged where R equals 0.28 and P equals 0.000. The test rejected the null hypothesis and concluded there was a correlation between the participants' savings and their stock valuation. The fifth hypothesis test is between savings and wallet. The following correlational test was conducted. Null hypothesis: there is no correlation between the participants' savings and their wallet amounts. The alternative hypothesis states there is a correlation between the participants' savings and their wallet amount. The correlation coefficient and its p-value were calculated using PSPP. Assuming alpha equals 0.05, a significant correlation emerged where R equals 0.91 and P equals 0.000. The test rejected the null hypothesis and concluded there was a correlation between the participants' savings and their wallet amount. The sixth hypothesis test is between stocks and wallets. The following correlational test was conducted. Null hypothesis: there is no correlation between the participant stock valuation and their wallet. Alternative hypothesis states there is a correlation between the participant stock valuation and their wallet. The correlation coefficient and its p-value were calculated using PSPP. Assuming alpha equals 0.05, a significant correlation emerged where R equals 0.19 and P equals 0.017. The test rejected the null hypothesis and concluded there was a correlation between the participant stock valuation and their wallet. As we can see from the correlational test and the scatter plot diagram of stock and wallet. Important takeaways: when a null hypothesis is rejected, the effect is said to be statistically significant. The correlation provides direction and strength between two variables. The p-value is a continuous measure of evidence. Scatter plots are used to plot data points to show how much one variable is affected by another. PSPP is an important tool to perform correlational tests. It is free to download. Decision making are faster and easier with correlational analysis tests. These are my references. Question and answers. Kindly use the comment box below for any question you have, and this will definitely be answered. Thank you for watching. Bye.